Well, I've read it. The difference between phase change and state change. Although that's not what this actually purports to tell me, is it? This purports me to change if you see the expression phase of matter or state of matter, what they both mean. It doesn't talk about changes of phase and changes of state. But look, a change in phase does not change the uniformity of matter. A change in state may or may not change the uniformity of matter. I don't think that's particularly helpful. I don't understand that. A state of matter can have several phases. A phase of matter can only have one phase. Well, that presumably is obvious, isn't it? A phase of matter has uniform properties, like an aqueous solution is an aqueous solution, but it doesn't have uniform properties of concentration. So, a phase of matter is the form of matter that has uniform chemical and physical properties. Well, a concentrated solution doesn't have the same physical properties as a less concentrated solution. A state of matter is a form of matter at a given temperature and pressure. Is the form of matter. The form of matter is the form of matter. A state of matter is the form of matter. That don't make no sense either. Really, does it? So I'm going to go now to the fact that we got 1 billion results. Is that right? Okay. The main difference between phase of matter and state of matter can be given as, phase of matter explains uniform chemical and physical properties of matter. Its phase explains uniform chemical and physical properties. No, because aqueous solutions have different boiling points, have different thermal what's the expression? Specific heat capacity that I'm looking for. Specific heat capacities, they change according to the concentration, and yet they're all aqueous phases. So I'm not satisfied with that, really, myself, and I'm not satisfied with that. Where are we going next? We better look what's the difference between phase and state of matter. And we're opening it up, and I'm about to find out, and suddenly the penny's going to drop. I don't think so. States of matter is a more specific and precise term than phases of matter. All right, well, I wouldn't normally use the expression phase of matter, but I would say that I would use the expression phase change. State of matter is the state of a particular compound in a physical system. The state of a particular compound in a physical system, whereas phase is a set of states within such a system. Phase is a set of states. Phase is a set of states. Phases are a set of states. No, I don't even like that one. I've been asked for the difference between phase change and state change, and I've got the difference between phase of matter and state of matter. So let's really go back to phase change. Is there any fundamental difference between phase? Sir, I would like to say that states are different forms at which matter can exist. So a particular state of matter, solid, liquid, gas, it talks about plasma and something else, Bose-Einstein condensate, I believe, is the form of the matter at a given temperature and pressure in a state not necessarily has uniform physical and chemical properties. While phase is defined as the region throughout which its physical and chemical properties, for example, density, refractive index, and we might add into that specific heat capacity and what have we got? Refractive index, density, specific heat capacity. What would be another example? Escapes me for a minute. Those all remain uniform. Although very often both these words are used synonymously, but there can be different phases even within the same state. Well, yes, that's because you can have allotropes. It is not because it is not essential. Although very often both these words are used synonymously, but there can be, well, the but is superfluous, there can be different phases even within the same state, because it is not essential to have uniform physical properties while considering the state of matter. That's terrible English. A system can also contain several immiscible phases of the same state. Several immiscible phases. Well, you can have two liquids floating one on top of the other. Well, if you can have two liquids floating one on top of another and say they're both in the liquid phase, I can say they're in aqueous solution or they're in solid crystalline form. P.K. Karamakar says, Dear Manoranjan, thanks for your reply. It's still unclear. Do you mean the following? State of matter with non-uniform physical and chemical properties. Phase, matter with uniform physical and chemical properties. References in support of your reply are welcome. It's really encouraging that you're interested in my answer. Adding to the discussion, I'd like to say I think the definition of state as matter with non-uniform physical and chemical properties would be too harsh, as in most of the cases a state of a particular matter shows uniformity over a long temperature and pressure regime, for example water. So for those cases the concept of phase and state almost exactly overlap. However, this is not universal, as phase change occurs in many metals, for example iron, cobalt, titanium, while still in the solid state. These phase changes are directly dependent on temperature and take place in the metal's crystalline structure. Well, okay, so you can have a phase change from solid to solid. Okay, we could read on. I think we will go on a little bit, and because but I know what I want to type up here to find out in a minute. There is a change in density between the kind of change in crystal structure of some metals while remaining in the same physical state, that is to say, while they are still solid, is known as allotropic transition, and all allotropic transitions are first order phase transitions, since there's no change in density between the two phases, and there is a change in density, and there is entropy, I think is what that word's meant to mean, difference between the two phases. Grey to white tin. Yes, sulfur undergoes different as well. Many references about allotropic transition are easily available. There are recent research as well which are easily available, and the fact that the allotropic transitions are indeed first order, yeah, right. So, when we come back to this in a minute, I shall type in, what shall I type in? Is the transition from aqueous to solid a phase or a state change transition? That's what I have to type into Google. Another 11 minutes wasted. Well, not wasted, clarified.